Imagine setting sail across the vast expanse of the ocean, the endless horizon stretching before you. The sea is a realm of both calm and chaos, with mysteries that defy all logic. For centuries, explorers have charted the oceans, but there are places on Earth where things don't behave as expected. Islands, in particular, seem to have a strange way of appearing and disappearing, often defying the very laws of nature. It's one of the most bizarre phenomena, a landmass suddenly rising from the sea, only to disappear again as if it had never been there. Take the story of Nishinoshima, an island that unexpectedly emerged in the Pacific Ocean. In 1973, a volcanic eruption off the coast of Japan gave birth to a small island, which grew steadily over the years. But in 2013, something unimaginable happened. Another eruption began to form an entirely new island, the second eruption of Nishinoshima. The island expanded rapidly, reaching heights and sizes that no one expected. Scientists and curious observers alike were fascinated by this sudden reappearance of land in the middle of the ocean. It seemed like the Earth itself was giving birth to something new. But this phenomenon wasn't as rare as one might think. Islands have appeared from nowhere in other parts of the world, leading some to question, could there be more hidden land beneath the surface, waiting to be uncovered by the right set of circumstances? Nishinoshima wasn't the only case. Another story that captures the imagination is that of Sandy Island, located between Australia and New Caledonia. In 2012, scientists conducted a research expedition relying on the most sophisticated navigation technology, only to find that Sandy Island, an island they had located on maps, didn't exist at all. The island, which was supposed to be in the South Pacific, appeared on maps dating back as far as the 1800s. It was even marked on modern maps, yet no land existed at the coordinates where it was supposed to be. The mystery deepened when they checked the data from satellites and GPS, all of which seemed to confirm the island's location. After further investigation, the scientists arrived at the coordinates of Sandy Island, only to find an endless expanse of open water. There was no island, no landmass, just ocean stretching endlessly as far as the eye could see. It was as though the island had never existed. How could this happen? How could something that was so clearly marked on maps for over a century just vanish without a trace? The discovery sparked a frenzy of questions and speculations. Some believed that Sandy Island was once real, but had sunk into the ocean over time, disappearing without warning. Others wondered if the island was never there in the first place. Could it have been a cartographer's mistake? A mirage of the mind rather than an actual piece of land? Could this strange island have been an anomaly of the maps? A ghost of sorts, haunting the ocean, existing only in the minds of sailors and map makers? The mystery surrounding Sandy Island is just one of many cases where islands have appeared, disappeared, or simply defied all expectations. The oceans, vast and largely unexplored, have long been a source of intrigue, and these disappearing islands only add to the fascination. Could there be more islands hidden beneath the surface, waiting to emerge at the right moment? Another theory is that islands like Sandy Island could have been formed by volcanic activity deep below the surface of the ocean. Volcanic islands can form when magma erupts through cracks in the ocean floor, and sometimes these islands grow rapidly, only to sink back below the surface once the volcanic activity subsides. This process could explain why some islands appear only to disappear a few years later, as the landmass becomes unstable and the volcanic eruption ceases. But it's not just volcanic activity that's responsible for these disappearing islands. There are also tales of islands appearing due to massive changes in sea levels or tidal shifts. Could it be possible that some islands were simply submerged by rising ocean waters, only to emerge again centuries later, briefly giving us a glimpse of what was once there? In 2009, researchers studying oceanography came across another anomaly in the Pacific. This time, it wasn't a missing island, but one that seemed to change in shape and size over a matter of days. The island was initially discovered through satellite images, only for those images to show it shrinking and growing at unpredictable intervals. It was like the island was playing hide and seek with the ocean, only to leave scientists scrambling for answers. These shifting islands raised more questions about the relationship between the oceans and the land beneath them, as well as what factors govern the sudden emergence or disappearance of landmasses. But how do these disappearing islands affect our understanding of the planet? For centuries, we've believed that the Earth's surface is relatively stable. But as we continue to uncover these disappearing islands, we realize just how much we still don't understand about the forces that shape our world. One thing is clear: the ocean is full of secrets, some of which are still waiting to be revealed. One of the most plausible explanations for disappearing islands is the complex world of plate tectonics. The Earth's surface is divided into a number of large and small tectonic plates, which float atop the semi-fluid mantle below. These plates are constantly moving, slowly but surely over millions of years. In certain areas, the movement of these plates can cause land masses to sink below the ocean's surface. One of the most well-known examples of this phenomenon is the Indian subcontinent. Over millions of years, the Indian plate moved northward, eventually colliding with the Eurasian plate. This collision led to the rise of the Himalayan mountain range and the Tibetan Plateau, but it also caused certain parts of the ocean floor to subside, creating underwater land masses. The process of subduction, where one plate is forced beneath another, is a major driver of geological activity, and it could explain why some islands seem to appear and disappear without warning. In fact, much of the Pacific Ocean is shaped by subduction zones, which are responsible for creating underwater volcanoes and new islands. Volcanic islands often emerge from the ocean as a result of tectonic movement and eruptions beneath the surface, when magma from the mantle rises through the Earth's crust. It forms volcanic islands, which can grow rapidly depending on the intensity of the eruption. These islands, however, can be short-lived. After the eruption subsides, the island may sink back into the ocean, leaving behind little trace of its existence. The process is not always quick. Some islands may remain above water for years, even centuries, before slowly eroding or sinking due to the shifting forces of the Earth. The famous Easter Island, for example, was once part of a much larger landmass, but it is believed to have gradually sunk as the Pacific Plate moved over geological time. While Easter Island itself remains visible today, the idea that it could have once been part of a larger region gives us insight into how other disappearing islands may function over time. Some islands disappear because of erosion caused by waves, wind, and rain. Over time, these natural forces can break down rock, eroding the island until it is reduced to nothing more than a submerged piece of land. This gradual process is particularly prevalent on islands that were formed by volcanic activity. The rock is often fragile and prone to erosion once the volcanic activity that formed them ceases. While this may explain the disappearance of some islands, it still doesn't account for those that seem to vanish almost overnight. Another factor to consider is the role of rising sea levels. Climate change has caused global sea levels to rise steadily over the past century, and this trend is expected to continue. Islands that were once above sea level are now being submerged by the increasing waters, leading to their disappearance. While this process is slow and gradual, the impacts are undeniable. Some islands have been lost to the sea entirely, while others have seen their coastlines recede dramatically. In the case of Sandy Island, some scientists have speculated that it could have been a victim of rising sea levels. If the island were once real, it could have been submerged over time due to the slow rise of ocean water. However, this theory does not explain why the island was visible on maps for so long, or why it suddenly vanished from modern satellite images. This is where the mystery deepens. The disappearance of Sandy Island challenges our understanding of how human-created maps and satellite imagery can sometimes fail to capture the dynamic and constantly changing nature of the Earth's surface. Even today, some scientists and geographers speculate that there may be a far more complex explanation for the mystery of Sandy Island. Could it be that the island existed at one point, but was eventually destroyed by natural forces such as volcanic activity or tectonic shifts? Or perhaps the island was never truly there, and the maps were simply the result of errors made by early explorers or map makers. It's possible that the island was simply a phantom landmass, a mirage of sorts created by optical illusions or inaccurate data. Some experts suggest that Sandy Island may have been an error in the charts, possibly created by faulty early navigation techniques. While the discovery of Sandy Island has raised more questions than answers, it's also prompted scientists to rethink how we use modern technology to study the Earth. It becomes clear that there's no one-size-fits-all explanation for these strange occurrences. From volcanic eruptions to shifting tectonic plates, the forces behind these islands are varied and unpredictable. But how do we track these disappearing landmasses in real time? How can we even know an island existed in the first place if it's no longer visible? Enter modern technology. The advances in satellite imagery, GPS tracking, and sonar mapping have revolutionized our ability to explore and study the Earth's surface. Where once humans had to rely on physical exploration and crude cartography, today's tools allow us to peer beneath the waves, track the movement of tectonic plates, and map the surface of the planet with unprecedented precision. Satellite imagery has become one of the most powerful tools in studying disappearing islands. Through a combination of high-resolution images and infrared sensors, satellites can capture detailed images of the Earth's surface, including areas that are difficult or impossible to reach by traditional means. These images are constantly updated, giving scientists a snapshot of the planet's dynamic changes over time. When it comes to disappearing islands, satellite technology is particularly useful in detecting subtle changes in the landscape. For example, areas that may have been above water in previous images could appear submerged in newer images, signaling the potential disappearance of an island. Satellite images also help identify land masses that were never documented in early maps, but may have existed for a period before being washed away or eroded. One of the most important aspects of satellite technology is its ability to monitor sea levels. As we've seen with islands like Sandy Island and others, rising sea levels due to climate change are contributing to the disappearance of some land masses. Satellites equipped with altimeters can measure the height of the ocean's surface with incredible accuracy. These measurements can be used to detect shifts in sea levels, offering critical insights into the ongoing process of island submergence. However, satellite images have limitations. They can't always capture the fine details of underwater topography, which is crucial for understanding the full extent of tectonic activity or volcanic eruptions beneath the surface. This is where sonar mapping comes into play. Sonar technology, which uses sound waves to map underwater surfaces, is another essential tool in the study of vanishing islands. Sonar mapping allows scientists to explore the ocean floor in detail, identifying underwater volcanoes, land masses, and other geological features. In some cases, it can even uncover hidden islands that were previously unknown to modern science. For example, when scientists began to investigate the area where Sandy Island was once believed to exist, sonar mapping revealed that there was no solid landmass beneath the water. Instead, the sonar data suggested the presence of deep underwater terrain. This raised further questions about the island's true existence. Was it ever really there, or was it simply a cartographical error? As sonar technology continues to improve, scientists can more accurately track the movement of tectonic plates, monitor volcanic activity, and discover new islands or submerged landmasses. This technology also enables researchers to monitor the health of coral reefs and the impact of ocean currents, which can all influence the appearance and disappearance of islands. But how do we know that the islands we are tracking today are not just temporary phenomena caused by natural forces? The use of long-term monitoring stations helps scientists gather data over extended periods, tracking changes in the ocean environment, sea levels, and plate movements. These stations can measure everything from temperature and salinity to underwater seismic activity, providing scientists with a comprehensive view of how the ocean floor is evolving. For instance, researchers use data from monitoring stations to track the movement of volcanic islands as they form and disappear. By closely monitoring these volcanic islands, scientists can predict when an eruption might occur, or when a previously dormant island might suddenly rise or sink. This real-time data helps scientists understand the underlying processes driving these changes and provides clues as to why certain islands appear and disappear in the first place. While these technologies have vastly improved our understanding of disappearing islands, they also pose new challenges. Despite the incredible advancements in satellite and sonar technology, there is still so much that remains hidden beneath the waves. The ocean is vast and largely unexplored, making it difficult to track every change in real time. The ocean is a restless artist, sculpting and erasing its creations without warning. Disappearing islands are just one way it reminds us of its power. To us, maps seem final, fixed, but they're really just a snapshot, a temporary image of a world constantly shifting beneath the surface. Every contour of the seafloor, every island, every trench is subject to change. And when a new island bursts through the waves, only to vanish weeks later, it forces us to ask how much we really understand about our planet. Some of these islands form dramatically, born from violent submarine eruptions that hurl ash and lava skyward. Others rise more quietly, a slow buildup of material until the waterline is breached. But almost all of them are fragile. Without solid rock to anchor them, they're vulnerable to erosion from wind, waves, and currents. The ocean is patient, but relentless. It will reclaim what's not meant to stay. Even so, for however long these islands exist, they become natural laboratories. Scientists rush to study them before they're gone, sampling soil, observing how life takes root, measuring the heat of freshly solidified lava. It's not just about geology, it's about biology, climate, even the story of life itself. Some birds are quick to colonize these new surfaces. Seeds drift in on ocean currents or are carried in the droppings of those birds. In weeks, a barren slab of volcanic debris can become something astonishing, the beginning of an ecosystem. But not all island stories are so short-lived. Some, like Nishinoshima, refuse to disappear. Since its emergence, it has undergone multiple eruptions, reshaping itself again and again. It's become an unpredictable fixture, sometimes growing, sometimes shrinking. In a way, it's alive, changing as the planet breathes. Its volcanic heart might keep it above water for decades, or it might cool and crumble back into the sea. Only time will tell. And while we're learning from these islands, we're also watching others vanish for good. Rising sea levels, driven by melting glaciers and thermal expansion, are swallowing low-lying islands across the globe. This isn't sudden or explosive like a volcanic collapse. It's slow, insidious, but just as final. Communities on islands in the Pacific and Indian Oceans are already seeing their homes disappear under encroaching waves. Their maps aren't just changing, they're erasing generations of history and culture. And what about the islands that were never there to begin with? Sandy Island, once marked on maps near Australia, was believed to exist for over a century before scientists finally sailed there and found nothing, just open ocean. Was it a cartographer's mistake, a mirage, or a volcanic island that briefly appeared, only to vanish before modern satellites could confirm it? These mysteries blur the line between legend and reality. They show how even our most trusted sources can be wrong, and how the ocean still has the power to fool us. Even myths begin to feel plausible. Stories of Atlantis, of sunken lands lost to time, may have echoes in real geological events. Massive undersea landslides, sudden island collapses, or tsunamis could easily have sparked tales that lived on for generations. We used to scoff at these stories, but the more we discover, the more we realize the ancient world may have been observing the same phenomena, without the tools to fully understand them. Technology gives us eyes where we once had only guesses. Satellites now track even the smallest surface changes, capturing the birth and death of islands in high resolution. Seafloor mapping reveals submerged features we never knew existed. Collapsed islands, sunken craters, and vast plateaus that hint at lost lands. It's like reading the planet's diary, one page at a time. And still, there's so much left unseen. The ocean covers over 70% of our planet, but we've explored less than 20% of its depths in detail. How many more temporary islands have come and gone unnoticed? How many more will rise tomorrow, reshaping coastlines, rewriting maps, and challenging our understanding of what's permanent? These disappearing islands aren't just geological curiosities, they're reminders that Earth is still wild, still mysterious, still capable of surprise. They teach us humility, because no matter how advanced our technology becomes, nature will always stay one step ahead. It forces us to stay curious, stay watching, and stay ready for the next ripple in the deep. So what will rise next? What hidden peak beneath the waves is waiting to emerge? And when it does, will it stay long enough for us to learn from it, or vanish before we even know it was there? These are the kinds of questions that keep oceanographers, geologists, and dreamers alike returning to the sea. Thanks for watching. If you found this journey into the world's strangest islands fascinating, don't forget to like, subscribe, and turn on notifications.